Wire cutters rest against concrete that still smells of German engineering. Precise, methodical, built to last 1,000 years like everything the Reich designed, with the particular arrogance of people who believe their empire will outlive geology itself. But Corporal Eddie Blanchard sees something different in the twisted metal and ceramic insulators that surround the Freya radar station's power distribution center. Not German invincibility, but German vulnerability disguised as strength. Not impenetrable technology, but elaborate engineering that creates its own weaknesses for anyone clever enough to recognize that complexity is often just simplicity, wearing a uniform and marching in formation. The radar dish rotates overhead with mechanical precision, its steel framework cutting the Norman sky into geometric segments, scanning for Allied aircraft with the methodical thoroughness that has made Luftwaffe interception so devastatingly effective across occupied Europe. Each sweep sends invisible fingers of electromagnetic energy reaching toward the horizon, feeling for metal signatures that don't belong in German airspace, calling down fighters that transform bomber formations into falling debris, and scattered parachutes and casualty reports that families read with increasing dread as strategic bombing campaigns prove more costly than pre-war planning had anticipated. But Eddie sees the Freya differently than the RAF intelligence officers who briefed him on its capabilities, differently than the SOE operatives who identified it as a priority target, differently than the engineering specialists who declared it impossible to disable without massive conventional assault that would require resources and casualties that current strategic priorities cannot accommodate. He sees it as an electrical system. Complex, sophisticated, impressively engineered, but still just wires and current and electromagnetic principles that follow physical laws regardless of the political ideology that arranged them into configurations designed to detect and destroy Allied aircraft. The mistake that will save thousands begins with Eddie's refusal to accept expert assessment about what can and cannot be accomplished by a single operative with basic electrical knowledge and improvised equipment. Military engineers have declared the Freya stations invulnerable to sabotage because their power systems are heavily protected. Their control circuits are sealed against tampering. Their backup systems provide redundancy that makes simple component destruction ineffective. But Eddie understands something about electrical systems that formal engineering education sometimes obscures. The more sophisticated the system, the more ways it can be convinced to destroy itself if you understand its operating principles well enough to turn its strengths into weaknesses. This is September 1943. The Battle of Britain has been won, but the war for European skies continues with the systematic intensity that characterizes industrial conflict, where victory belongs not to the brave or the clever, but to whoever can maintain superior production rates of aircraft, pilots, and technical systems that provide tactical advantages measured in seconds and percentages. The German radar network across occupied France represents one of those technical advantages, allowing Luftwaffe fighters to intercept Allied bombers with efficiency that transforms strategic bombing from war-winning capability into expensive attrition that favors defenders who need only to survive rather than advance. The Allied response has followed conventional military logic. Bombing raids against radar installations using massive formations that accept heavy losses to destroy static targets. Commando raids that require significant personnel and provide temporary disruption at best. Electronic jamming that creates interference, but cannot eliminate the fundamental detection capability that allows German fighters to find and destroy Allied aircraft faster than replacement training programs can produce new crews. Each approach treats the radar network as a military target requiring military solutions, firepower and manpower, and the kind of direct assault that conventional warfare doctrine prescribes for destroying enemy installations. But Eddie Blanchard brings a different perspective to the problem. Before the war, he worked as a civilian electrician in Montreal, installing power systems in office buildings and factories, troubleshooting electrical problems that required practical understanding rather than theoretical knowledge, dealing with the reality that electrical systems fail in ways that engineering textbooks never describe and must be repaired using methods that regulations never anticipate. His military training at CFB Petawawa taught him demolition and sabotage, but his civilian experience taught him something more valuable: how electrical systems actually behave when stressed beyond their design parameters, how complex circuits respond to inputs they were never intended to receive, how sophisticated automation can be convinced to operate in ways that benefit operators rather than designers. The infiltration into occupied France happened through established SOE networks that specialize in moving personnel and equipment across borders that exist more on German maps than in French reality, where resistance organizations maintain transportation routes and safe houses that allow Allied operatives to move through territory that official sources consider impenetrable. Eddie's cover as a maintenance worker provides access to industrial facilities where electrical knowledge appears routine rather than suspicious, where his questions about power systems seem motivated by professional curiosity rather than military intelligence gathering. The Freya station outside Caen represents a typical installation of the German radar network. Massive concrete emplacements protecting sophisticated electronic equipment, defended by sufficient personnel to repel conventional assault, integrated into communication systems that coordinate air defense across the entire Atlantic Wall. Intelligence reports describe it as one of 12 stations that provide overlapping coverage of the invasion approaches that Allied planners will eventually need to penetrate when cross-channel operations begin in earnest. Destroying or disabling the Caen station would create a gap in German radar coverage, but conventional assault would alert other installations and trigger defensive responses that would eliminate whatever tactical advantage the destruction might provide. Eddie's first reconnaissance of the installation reveals what intelligence reports had failed to emphasize. The Freya's sophisticated electronics require enormous amounts of electrical power, delivered through systems that represent the best of German electrical engineering, but also the complexity that such sophistication demands. The radar dish itself draws over 200 kilowatts during operation, requiring step-up transformers, voltage regulation systems, backup power generation, and control circuits that coordinate everything from antenna rotation to signal processing to communication with fighter command centers that direct interception missions. The power distribution system fascinates Eddie more than the radar technology itself. German engineers have created electrical infrastructure that could power a small town, with redundancy and automation that ensures continuous operation even when individual components fail or require maintenance. But Eddie recognizes something that radar specialists have overlooked. The very sophistication that makes the system reliable also makes it vulnerable to the kind of creative electrical manipulation that can turn protective circuits into destructive ones, safety systems into sabotage mechanisms, automated controls into weapons that destroy the equipment they were designed to protect. The plan that emerges from Eddie's analysis violates every principle of conventional sabotage. Instead of destroying components, he intends to modify them. Instead of interrupting power flow, he plans to redirect it. Instead of damaging the radar system directly, he will convince it to damage itself using its own operating energy, its own control circuits, its own protective mechanisms turned against the equipment they were installed to preserve. It's electrical jujitsu, using the opponent's strength and momentum to create their own destruction. The technical challenge involves understanding how German electrical engineers designed their power systems, what safety margins they built into their equipment, what protective circuits they installed to prevent the kind of catastrophic failure that Eddie intends to create. The Freya operates on principles that are universal: electromagnetic radiation, power amplification, signal processing, but the specific implementation follows German engineering standards that emphasize robustness, redundancy, and the kind of over-engineering that assumes hostile operating conditions and attempts to provide functionality regardless of external stress. But over-engineering creates vulnerabilities as well as strengths. The multiple backup systems that ensure continuous operation also provide multiple pathways for electrical manipulation. The safety circuits that protect expensive equipment from damage can be rewired to cause the damage they were designed to prevent. The automated controls that provide sophisticated operation without human intervention can be modified to perform operations that no human operator would ever intentionally command. Eddie begins his work during the shift change between day and night operations, when personnel attention focuses on briefings and status reports, rather than routine monitoring of systems that have operated reliably for months without requiring significant maintenance or adjustment. The power distribution center that serves the radar installation occupies a concrete bunker separate from the main radar housing, connected by armored cables that carry high-voltage power and low-voltage control signals between the generating equipment and the detection systems that depend on steady, reliable electrical supply. The German electrical systems prove both more and less sophisticated than Eddie expected. More sophisticated in their automation and redundancy, with control circuits that provide capabilities he had not anticipated, and safety systems that represent excellent engineering practice. Less sophisticated in their security, with access panels that can be opened using standard electrical tools, control circuits that can be modified using conventional wiring techniques, protective systems that assume mechanical failure rather than deliberate sabotage, and therefore lack the kind of tamper-resistant features that would prevent unauthorized modification. The critical insight comes when Eddie realizes that the Freya's power amplifier systems, the circuits that boost radar signals to the strength necessary for long-range detection, can be turned into weapons if their output is redirected from the antenna system back into the radar's own control circuits. The same electrical energy that creates detection capability can destroy detection equipment if it's routed through components that were designed to handle signal processing rather than power transmission. It's like convincing a loudspeaker to play a sound so loud that it destroys itself. Except the loudspeaker is a radar system worth more than most people earn in a lifetime. The modification requires careful rewiring of circuits that were never intended to interconnect, creating electrical pathways between systems that German engineers deliberately separated to prevent exactly the kind of interaction that Eddie plans to create. He must bypass safety circuits without triggering alarms, redirect power flows without causing immediate system shutdown, and time the modification so that the destructive feedback occurs during peak radar operation when maximum energy is available for redirection into vulnerable components. Working by flashlight during the brief periods when guard rotations provide access to the power distribution center, Eddie begins the delicate process of transforming German engineering precision into German engineering destruction. Each wire he moves, each circuit he modifies, each connection he redirects brings the radar system closer to a condition where its own operating energy will destroy the equipment it was designed to power. The work requires the kind of electrical intuition that comes from years of practical experience with systems that don't behave according to theoretical specifications, that develop quirks and characteristics that textbooks never describe, but working electricians learn to anticipate and accommodate. The most dangerous part of the modification involves the timing circuits that control when the destructive feedback will occur. Eddie needs the system to operate normally for several hours after his modification, long enough for him to extract safely and for German technicians to dismiss any minor irregularities as routine operational variations rather than evidence of sabotage. But he also needs the feedback to occur during peak operational period, when the radar is actively scanning for Allied aircraft. when maximum energy is flowing through the systems he has modified, when the destructive potential of his electrical manipulation will achieve maximum effect. The solution involves using the radar's own operational schedule against itself. The Freya operates on predictable patterns, with increased activity during periods when Allied bombing missions are most likely, with power fluctuations that follow standard operational procedures for equipment, warm-up, peak operation, and maintenance cycles. Eddie designs his modification to exploit these normal variations, using the radar's own operational rhythm to trigger the electrical feedback that will destroy it from within. The technical execution requires precision that leaves no margin for error. One wrong connection could trigger immediate system failure that would alert German technicians to sabotage and lead to security responses that would compromise Eddie's extraction and eliminate any possibility of replicating the technique at other installations. But perfect execution could create a new form of sabotage that appears to be equipment failure, that provides no evidence of external interference, that could be repeated at radar stations across occupied Europe without alerting German engineering teams to the vulnerability that Eddie has discovered. When the modification is complete, the Freya radar station looks identical to its condition before Eddie's infiltration. The power distribution systems show no visible signs of tampering. The control circuits appear to function normally during routine operational checks. The antenna continues its methodical rotation, scanning for Allied aircraft with the same mechanical precision that has characterized its operation since installation. But beneath the surface appearance of normal operation, electrical pathways now exist that will transform the radar's next period of peak activity into a catastrophic feedback loop that will destroy millions of Reichsmarks worth of sophisticated detection equipment using its own operating energy. Eddie's extraction from the installation area follows the same careful procedures that brought him to the target, using resistance networks that understand how to move people through territory where detection means torture and execution for everyone involved in the operation. But extraction carries additional tension, because the success or failure of his mission will not be known until the modified electrical systems trigger the destruction he has designed, until the radar attempts its next high-power operational cycle and discovers that its own energy has been turned against its own survival. The explosion, when it comes 18 hours later, destroys not only the radar dish and its supporting electronics, but also the power generation equipment that Eddie's modification convinced to operate beyond safe parameters, creating electrical fires that consume backup systems and control circuits and documentation that might have helped German engineers understand what caused the catastrophic failure. The destruction appears to result from equipment malfunction rather than enemy action, from the kind of technical failure that sophisticated systems occasionally experience when operated under the stress conditions that wartime demands impose on equipment designed for peacetime reliability standards. German investigation teams find evidence of electrical fire, of power surges that exceeded equipment specifications, of control circuit failures that created cascading system breakdown. But they find no evidence of external sabotage, no indication that enemy agents penetrated their security, no suggestion that the destruction resulted from anything other than the kind of technical failure that complex electrical systems sometimes experience when pushed beyond their design limitations by operational demands that exceed peacetime engineering assumptions. The intelligence value of Eddie's success extends far beyond the destruction of a single radar installation. His technique proves that sophisticated enemy technology can be turned against itself using methods that require electrical knowledge rather than massive firepower, individual infiltration rather than large-scale military assault, creative thinking rather than conventional destruction. The Freya stations that seemed impregnable to direct attack prove vulnerable to indirect manipulation that uses their own sophistication against their own survival. SOE technical teams begin developing Eddie's improvised sabotage technique into standardized procedures that can be taught to other operatives, creating training programs that focus on identifying electrical vulnerabilities in enemy installations rather than planning conventional demolition operations. The principles that Eddie discovered through practical experimentation become formal doctrine for operations that target enemy technical systems using their own complexity as a weapon against their continued functionality. But the broader implications extend beyond immediate military applications. Eddie's success demonstrates that technological sophistication creates vulnerabilities as well as capabilities, that complex systems often contain the seeds of their own destruction if operators understand their design principles well enough to exploit them creatively. The same engineering excellence that makes systems reliable and efficient also makes them vulnerable to manipulation by people who understand their operating principles better than their designers anticipated. The technique spreads to other theaters of operation where similar radar installations provide enemy advantages that conventional attack cannot eliminate cost-effectively. Resistance organizations across Europe receive training in electrical sabotage that turns enemy infrastructure against itself, creating system failures that appear to result from technical malfunction rather than enemy action. The psychological effect on German technical personnel proves as valuable as the physical destruction, creating uncertainty about the reliability of sophisticated equipment and forcing the allocation of engineering resources to solve problems that have no technical solution because they result from deliberate human intervention rather than mechanical failure. When the war ends, Eddie returns to civilian electrical work, carrying knowledge that proves valuable in peacetime applications, where complex systems require maintenance and troubleshooting by people who understand how electrical equipment actually behaves, rather than how engineering specifications say it should behave. His wartime experience with turning electrical systems against themselves influences his post-war career in industrial maintenance, where the ability to diagnose and correct complex electrical problems makes the difference between profitable operation and expensive downtime. But more importantly, Eddie's refusal to accept expert opinion about what was impossible creates precedent for technological innovation that extends far beyond electrical sabotage. His success demonstrates that specialized knowledge can become limitation when it prevents recognition of unconventional applications. That expertise in one field can blind practitioners to possibilities that generalists might recognize. That practical experience often reveals opportunities that theoretical knowledge overlooks. The principles that Eddie applied to radar destruction, understanding system vulnerabilities, exploiting design assumptions, using complexity against itself, these concepts influence post-war development of electronic warfare, computer security, and the emerging field of cybernetics, where complex systems must be protected against exactly the kind of creative manipulation that Eddie pioneered under combat conditions. His wartime improvisation becomes foundational knowledge for peacetime applications that require understanding how sophisticated technology can be convinced to operate in ways that serve operators rather than designers. Years later, when electronic warfare specialists design systems to disrupt enemy communications and radar installations, they study wartime sabotage reports that include Eddie's Freya station destruction, learning how electrical knowledge can be weaponized against electrical equipment more effectively than conventional explosives. The techniques he developed under survival pressure become formal military doctrine for operations that target enemy technology using technological methods rather than kinetic destruction. The concrete bunker that housed the Freya radar station remains visible in the Norman countryside, but the sophisticated electrical systems that once coordinated air defense across occupied France exist only in engineering documentation and historical reports. Sometimes, when electrical storms move across the landscape where Eddie performed his careful rewiring, local residents report unusual electromagnetic effects that seemed to emanate from the abandoned installation. Residual evidence, perhaps, of the moment when one Canadian electrician proved that the enemy's technological strength could become their technological weakness. If someone understood electrical principles well enough to turn German engineering excellence against German military. Objectives. The spark that Eddie created when he redirected the Freya's own power back into its control circuits lasted only microseconds, but its effects changed how military planners think about technological vulnerability, how engineers design protective systems, how operators understand the relationship between complexity and security. The explosion that destroyed millions of Reichsmarks worth of sophisticated radar equipment began with wire cutters and electrical knowledge and the willingness to question expert assessment about what sophisticated technology could and could not be convinced to do when operated by someone who understood its principles better than its limitations. If stories like this remind you that technological sophistication often creates its own vulnerabilities, that creative thinking can turn enemy strengths into enemy weaknesses, then perhaps there are other moments when refusing to accept expert limitations created breakthroughs that changed how we understand the relationship between knowledge and possibility, between complexity and security, between following procedures and questioning assumptions about what technology can be convinced to accomplish when survival depends on seeing opportunities where expertise sees only obstacles.